Welcome once again to my channel and welcome once again to the next lecture of physics optional for UPSC CSE. And let us learn now this particular question, which says something like this: that having gone through a plank of thickness h, there is a plank which has a thickness h, and a bullet when pierced through it, the bullet when entered the plank of thickness h, it actually changed its velocity from v0 to v. Okay, find the time of motion of the bullet in the plank. We have to find out the time, and assuming that the resistive force. Okay, over here it should be resistive, not resistance. It should be resistive force over here. Okay, just make a correction, write resistive force over here. Okay, so assuming the resistive force to be proportional to the square of the velocity. So let us see this question, that there is a plank. The figure must be there in the next page. So you can see there is a plank of thickness h, and the bullet has entered with a velocity v0, and it is turning into a velocity v after a certain time t. Okay, let us assume that the time required in this process is suppose t. Okay, then in t time we have to find out the time t. It is not given to us, we are assuming it to be t, so we have to find the t value of small t in terms of v0, v and h. Okay, so equation of motion of the bullet is like this, obviously. Why? Because there is no other force acting on the bullet, so mass into acceleration. Okay, if we draw the free body diagram of the bullet, then what will happen? Mass into acceleration will be written as the net external force, and the net external force is the resistive force only. Okay, the resistive force offered by the plank. So this is the resistive force offered by the plank. Why? Because the resistive force was proportional to v square, and when we remove the constant of proportionality, k dash will come. And mass into acceleration, let us write the acceleration to be dv by dt. Okay, so what will happen then? This k dash will become k with the help of this m coming to the right hand side, and this dv and this v square, we undergo the, we do the variable separation method. Okay, so after separating the variables, this dv and v square, these two things come together, this dt comes over here. Okay, as already told to you, multiply both side by dt, saying so is very wrong. Okay, why? I have already told you in the previous lectures. So dv by v square equal to minus k dt, where k equal to k dash by m, because this m had been divided over here, so k dash by m will be equal to k. dt will be, after variable separation, dt will go to the right hand side, and this dv by v square will come over here. Then we know this very well. What will be the limits of this integration of this v? Limits of integration of this v, what they will be? So they will be basically from v0 to v. Okay, so if you integrate over here, they will be from v0 to v. And what about this dt? It will be from 0 to t, right? Because time t equal to 0 will start over here, and time t equal to t will be over here. So t time has elapsed, so integration 0 to t will be there. So substituting the corresponding limits, we get something of this kind. Okay, and after you basically simplify this, what will happen? dv by v square is there, dv divided by v square. So when you take the v square to the numerator, it will be v to the power minus 2, and when you integrate v to the power minus 2 dv, what will happen? V to the power minus 2 plus 1 divided by minus 2 plus 1. Okay, so it will be minus 1 by v. I hope this much simpler integration you know already. Okay, so 1 upon v, v0 to v, this will be equal to minus kt, this right hand side quantity, and this will be 1 by v minus 1 by v0 equal to kt, then v naught minus v divided by v naught v equal to kt. So we have found out t successfully from here. V naught minus v divided by k v naught v. This is suppose your equation number 1. Okay, in equation 1 k is not known. Okay, because we have assumed the k. Okay, we had to find out t in terms of the known variables only. We had to find out this time t in terms of known variables only. So you have only 3 known variables over here. What are the 3 known variables? V naught is a known variable, v is a known variable, and h is a known variable. But the other things, okay, what other things? This k dash you yourself have assumed, this k you yourself have assumed, and you have got t in terms of v naught minus v. These terms are all right. V naught is all right, v is all right, v naught is all right, v is all right. But the term k, it is from our assumption. So we will have to eliminate this k in order to obtain our quantity time in terms of the given quantities only, not the ones which we have assumed. So k we have assumed, so we will have to eliminate this particular k from here. Okay, so how will we eliminate it? So k is not known. To find the value of k, we write the equation of motion in the form like this. Okay, so in order to find the value of k, what will we do? We will in the place of mass into acceleration, we will write v dv by ds. Okay, now what is this? You must be knowing that acceleration is equal to v dv by ds. How does this come? Okay, so this is your equation of motion. Now dv by ds, if you want over here, then what will happen? You will have to do some simplifications. Okay, so the thing is, I will do it on the right hand side for you. I will do it on the right hand side for you. Okay, over here. So let us do the manipulations. What is there? M dv by dt, that is mass into acceleration, that is equal to your minus k dash v square. Okay, now if we want to represent them like this as given over here, we have to eliminate basically t. Now acceleration is equal to dv by dt, we know this very well, and ds by dt is equal to your v, right? Now just write dt like this, ds over v. Okay, so now we wrote dt as ds over v. Now substitute this dt over here. What will happen? ds divided by, okay, sorry, dv we have eliminated t, so dt will come over here. Okay, so it will be ds divided by v. So it will be, this v will go in the upward direction. So what will happen? This v from here it goes over here. So v dv ds. So your acceleration is equal to v dv ds from here. So a comes out to be v dv ds divided by ds. Okay, v dv by ds. So this is the thing. After eliminating the time variable, the time differential dt, you get something like this. Now what will we do? We will actually separate the variables. So after separating this m will go to the right hand side and k dash by m will appear over here. So k dash by m will be equal to k. So this is your k, and this v square will go here, ds will go here. Okay, so dv by v equal to minus k ds. Now on integrating, why are we doing all these things? So that we can actually eliminate this k. How will we eliminate this k? We have to eliminate this k from here. So in order to eliminate that k, we are basically doing all these things. So we will integrate for the entire motion. So ds is your from 0 to h, and velocity has changed from v naught to v. When the motion of the bullet had started, at that time the displacement was 0, and at the final time the displacement is h. Okay, and initially the velocity of the bullet was v naught and the final velocity is v. So you are doing like this. Then this will be ln v, then ln log a minus log b equal to log a by b, you can see. So ln v by v naught, then this is minus k, ds will become s, h minus 0 will come, then minus kh, and successfully we have found out the value of h also, k also. So this is suppose your equation 2. Then what will we do? As we have found out the value of v in terms of all the known variables. So known variables are h, v naught and v as given in the question. So from here this value of k, as we have found out them to be in terms of the given variables, so we can successfully substitute this k value in this equation 1, which is already we have found out earlier. So in the place of k, all these variables, all these terms you can substitute. So after you substitute them, what will you get? You get something like this: t equal to h, okay, t equal to h v naught minus v naught v ln v naught by v. So this is the thing which you get. So this is the expression for time. Now what is this? This is your expression for time. So this is your final answer. So remember, in the examination some students are very blunder mistake makers. So what do? They actually find out up to here, okay, they actually find out up to here and say that we have arrived the answer. You have not arrived the answer yet. If you do up to here only, then you have not arrived the answer actually. Why? Because this k variable has been assumed by you, it is not given in the question. So if you assume something, you have to turn it in terms of the given variables, okay. So the given variables are only 3: v naught, h and v. Even the t which we have assumed, that is also an assumption, okay. So only 3 things are given: v naught, v and h. So in terms of them only you have to calculate everything. So you will have to eliminate the term k from that particular t expression, and after you eliminate the variable k from that t expression, you get the thing like this. This is your final answer. Final answer, okay. Let's move on. Now what is there? A body of mass m is thrown straight up. We will do it in the next class, okay. This particular question, a body of mass m is thrown straight up and all these things, we will do it in the next class. So till then you can note this question down in your notebook and surely can solve it. Thank you.